this screencast, we are going to look at how you reverse the process from going from a organic name of a compound into drawing what it looks like structure-wise. So the basic process, I would go with 2 steps. You first need to draw the chain, and then you need to add any multiple bonds or attach groups or branches. So in the case of 2,4-dichloro-2-pentene, I see that I have a pentene, which means I have 5 carbons. So 1, 2, 3, 4, 5. And I see that it is an ENE, which means on carbon 2 I have a double bond. So I'm going to count over 1, 2, and I'm going to put a double bond. And then on my second and fourth chlorine, on my second and fourth carbon, I'm going to have a chlorine. So 1 chlorine and 1 chlorine. And it doesn't really matter what side you write them on. I'm just sharing equal, I'm going with symmetry. So the remainder of the bonds would be filled with hydrogens. So I have the rest of my bonds filled out with hydrogen. Remember, I want to have 4 bonds on each carbon. So the first one gets 3. The second one doesn't get anything because it already has 4 bonds touching it. The third one gets 1, the second one, or the fourth one gets 1, and then 3 again. So when you condense this, we would have CH3, CCl, and some people would put this in parentheses. Here, let me rewrite that because it looks a little messy. Some people would write that in parentheses, Cl. Then they'd show the double bond. Then CH, C. We're going to go CH with another Cl in parentheses, and I've run out of room. There should be a CH3 on the end. So if I were to write that again down here, real much neater, CH3, C, Cl, double bond, CH, then my CH with my Cl branched and my CH3. So that is 2,4-dichloropentene. Here's another example, giving you the name and asking you to draw the structure. 4,5-dichloro-6-methyl-2-hexyne. Okay, so we have a hex, which gives us a 6-carbon line. 1, 2, 3, 4, 5, 6. Now this is something I've made up, so who knows what's going to happen here. So 6 carbons, and actually that's not 6 carbons, that's 7. So now we have 6 carbons. We have a YNE and right here, and it's on the second carbon, so that tells me that I have a triple bond. So my triple bond goes there. And then I have my branches. So on carbon 4 and 5, I have chlorine. So 1, 2, 3, 4. I'm going to have a chlorine here and a chlorine here. And on carbon 6, I have a methyl, which really doesn't make sense because then our longest continuous chain would be a 7 group. So let's finish drawing this out and we'll fix that. We have all the branches in, we have everything we need, so we're just going to go back in and make sure that we have 4 bonds on everything and fill in with our hydrogens. This one gets 2 hydrogens. So if we were to write the condensed version of this structure, we have CH3, we have C triple bond C, we have CH with a Cl branched, then we have that again, CH with a Cl branched, and then we have a CH2 with a CH3 branched. Okay, now another name for this entire structure, if you go with the longest continuous chain, we have 1, 2, 3, 4, 5, 6, 7. So this would be a heptyne, would be a better name for this. And it's still on carbon 2. And we have on 4 and 5, we have our dichloro. So sometimes when you're making things up, you realize that what you made up doesn't actually make sense. So you can see here how we fixed this version to have a better structure. Again, just whenever you are going in the reverse, you need to draw the longest continuous chain, add in the multiple bonds, and then add your attached groups, and that's how you go from the name to the structure.